Introducing Bolt, a fully autonomous robot that scales walls, traverses mountains, and launches weapons of mass destruction. But how do we get here? At first, we thought we could take the template project, slap on 2 giant wheels with rubber tires for better grip and leverage, and it will somehow work. But
I think this is the end of this design.
Yeah.
so the idea was scrapped pretty quickly. We moved on to 4 wheels as we'd rather be normal and succeed than be special and fail. We also rebuilt the body and wheels from scratch because the template project body was quite literally falling apart. We continued to use cardboard so we could fold walls to improve structural integrity and keep everything inside. We definitely made sure to make the grain of the cardboard lie parallel to the robot, because otherwise the robot would sag in the middle, like a recruit doing his 3rd set of planks in a 4 for a core exercise. Like, who would make such a basic mistake? Not us, that's for sure. Tires fall apart after many kilometers of intense racing. The tires on our first prototype fell off after 50 centimeters, about a distance from the starting box to the first obstacle, which was the furthest it ever went anyway. This was because hot glue sucks, henceforth known as HGS. And by scratch, I really meant asking our wonderful and hardworking TAs to use a laser cutter to cut out acrylic wheels for us, because a computer is much better at drawing and cutting circles than I am. The wheels were spoked, not only to reduce weight, but also to help us use tape to attach the new and improved tires made out of
anti-slip mats
to our rims. Attaching the wheels and motors to the body was simple. Not HGS. So the motors kept falling off like how lizards lose their tails when spooked. Turns out that hot glue was strong enough at resisting tension, but easily fell apart once there was any rotational force, which was exactly the kind of force our wheels were exerting on the motor body bond. To combat this, we used tape to prevent the motor from tilting while the glue kept the motor actually attached to the body. We used hazard tape, not only because you can, and also because it was stickier, stronger, and better looking than the masking tape provided. Getting the motors to run wasn't easy either. At first, we followed the template project and used a 6V battery pack to power the motors and a 9V battery to power the Arduino. As it turns out, 6V wasn't enough for 4 motors. We needed more power, so we used the 9V to power both the Arduino and the motors. Sure, the robot would stop running after like 5 minutes, but we really only needed it to run for 30 seconds anyways. To get the ball over the wall, we added an extension to the cardboard frame that allowed us to fold a raised platform to attach a servo motor and arm to. That way, when the arm is raised, it will be tall enough to send the ball over the wall without needing much more force. Without the platform, the arm will have to be around 30 centimeters to get the ball over the 30 centimeters wall, which will make the robot too long to fit in a 30 centimeters box. Another rookie mistake that we definitely did not make. Because HGS, the servo motor is securely attached to the platform using a rubber band, which I thought was pretty smart, yeah.
So after all this, have you wondered why we named our robot Bolt? Here's why.
Set.
They get away first time. Tyson Gay right alongside Usain Bolt, but here he goes, streaking away already. It's Bolt all the way. He's looking round at Gay. Watch the clock. It's goal for Bolt, and again he's done it again.